Welcome back. Today we are going to talk about equations of lines, and we are going to learn how to find the slope and graph linear equations. And a couple of things that you'll need to remember from your Algebra 1 days is the definition of what the slope is and what that tells us about a line. And remember, a slope is the vertical change or the change in y, which we often called the rise, over the horizontal change, which we called the run. And you may have remembered this formula, y2 minus y1 over x2 minus x1. That's just the difference in the y coordinates of any 2 points divided by the difference of their x coordinates. So it's just the rise over the run. To find the slopes of lines, we're going to use that slope formula, which is given right here. It says, what is the slope of line B? Now line B is the red line right here that you'll see in the video here. Line D is the blue one. So for part A, we're going to look at line B. And we have the coordinates of points A and B indicated on our graph. So it says to use the formula for slope to go ahead and find what the slope of that line is. And I'm going to let A be x1, y1, and B be x2, y2, so that my slope will end up being the difference of y2 minus y1. So I'm going to use negative 2 minus 2 divided by x2, which is going to be 4 minus a negative 1. So simplifying this, negative 2 minus 2 gives me negative 4 in the numerator. In the denominator, I have 4 minus a minus 1, which is 4 plus 1, which is positive 5. For line D, and let me go ahead and check, I think I have an answer on the side here. Negative 4/5 is what we should have had, so that one turned out correct. For line D, what is the slope of line D? And again, we have the 2 coordinates here, and it doesn't matter which one you start with, as long as you're consistent. So my slope for line D is going to be y2, which I'll call negative 2, minus y1, which is 0, divided by x2, which is 4, minus x1, which is 4. Well, you can see in this situation we're going to run into a problem. In the numerator we get negative 2, but the denominator we get 0. Anytime we get 0 in a denominator, we say that it has an undefined slope. So you just write undefined. We cannot divide by 0, so that is an undefined slope. Here's an opportunity for you to go ahead and try to find the slope of line A. For the first part, part A is the red line, find that slope. And in part B, find the slope of the blue line, C. Go ahead and pause your video. Alright, I hope you had a chance to give that a try. Let's go ahead and take a look at what kind of answers we get. For letter A, what is the slope of line A? Well, line A, we have the point 5, 7 and the point 2, 3 are given here. So 5, 7 I'm going to use as my y2. So I'm going to do 7 minus 3 divided by, remember these are the y coordinates, 7 here and a 3 here. And I'm going to divide that by the the x coordinates then are 5 minus 2. So that should give me in the numerator, I have 7 minus 3 equals 4. In the denominator, I have 3, so my slope is 4/3. How about letter B? What is the slope of line C? Well, for line C, that's the blue line here. It's a horizontal line. Let's go ahead and use our slope formula. y2 is 7, y1 is 7, x2 is 5, x1 is 1, so we end up with 0 over 4. Now it's okay to have 0 in the top number. We can have 0 in the numerator. That just gives us a slope of 0, so our slope is 0 for line C. So here are the 4 situations that you will run into with slopes of lines. You can have a positive slope, a negative slope, a 0 slope, or an undefined slope. Anytime you get a 0 slope, we have a horizontal line. Anytime you get an undefined slope, it's a vertical line. And we're going to be using 2 different slope formulas for our equations. when we get into writing our linear equations. The first one is the slope-intercept form, and that is y equals mx plus b, where m is the slope and b is the y-intercept. Remember, the y-intercept is the point where it crosses the y-axis. And then we also have the point slope form. If we know the slope and a single point on the line, we can use this formula, and that says y minus y1 equals mx minus x1. And x1 and y1 are just coordinates of a single point on the line. Well, let's go ahead and take a look at how to graph some of these equations. This is in slope-intercept form, and we always start with the y-intercept, okay? Our y-intercept is the number right here. It's +1. So we're always going to start with that point. So make a dot at +1 on the y-axis, and then use your slope from there. Remember, it's rise over run, so the +2 is the vertical change over horizontal change. So from the point I've already graphed, you don't go back to the origin, you go to the y-intercept as your starting point. You go up 2 and right 3, and you can make another dot. Up 2 and right 3, 1, 2, 1, 2, 3, and we make those dots. Now this is going to be pretty rough for me to do here freehand, so I'm going to cheat a little bit and go ahead and use my tools to make a straight line. It'll just make it a lot easier for you to see. It'll be a lot neater here. So I'm going to go ahead and try that and see if we can get there we go. So our line's going to look something like that. What is the graph of this one? Y minus 3 equals -2 times x plus 3. Well, this one's a lot different. This is not in our normal point slope, or excuse me, our slope-intercept form. This one's in point slope form. So we know that the slope is -2, and we know it goes through the point 3, -3. So I'm going to go ahead and write that up here because those are significant pieces of information. So our slope is equal to -2. And we know it has this point on the graph, -3 for the x-coordinate and +3 for the y-coordinate. Whoops, didn't mean to move that. I got those coordinates from the x-coordinate there and the y-coordinate here. Remember, it's y minus y1, so this tells us what y1 is. This tells us what x1 is. But it's the opposite of that, so that's where the negative came from, just in case you're wondering. So to graph this, we're going to have a negative slope, and we have one point that it goes through. So let's go ahead and graph our point. So -3, 3 would be this point right here. We go left 3 and up 3. Remember, negative directions are left and down. Positive directions are up and right. And remember, this is our x-axis here, and our y-axis is up on top. So there's one point on my line right there, kind of messy, but that's one of the points. And then use your slope from that point. Now, a -2 slope, we need to have it as a fraction. The top number is the y direction, so we're going to go down 2, and then a +1 x direction would be to the right. And then we can keep going from there. Go down 2 and to the right 1. Down 2 and to the right 1, and you could continue this forever. Or the other thing we could do is we could think of our slope as a +2 over a -1. It doesn't matter where you associate that negative sign. We could go up 2 and left 1, and that would give us some more points on our line. So that's kind of what our line would look like. Let me go ahead and graph that line again. Again, I'm going to use my tool here to make it a little bit straighter line. Oh, it didn't work for me. Let me grab that again. Okay, there it is. Oh, I see what I did. Okay, let's try this again. There we go. See, much better. Works a lot better when I'm using the line tool. Here are a couple for you to try and bring to class. Both this slide and the next slide. This one is in slope-intercept form, so you're going to start with your y-intercept and then use your slope. The last slide is in point slope form, so you have the slope and you have a single point, and you'll start with the point that's on the line and use your slope to find another point. We'll see you next time.